So are we ready, guys? I think you got a week where several of the students went to a conference. I think the NAPSing around, we say. It's called NAPS, National Association of Power Students, and so they're presenting there. But I think we have a very interesting seminar today. It's about a very important part of the electric utility business, and this is the co-ops. The co-ops are important because they were very much involved with the electrification of the U.S. It was part of the New Deal. I did it in 1935 when FDR was in power. And since then, I think U.S. is probably one of the few countries which practically is 100% electrified.
That's right.
And Bob is going to be here. He's president of the co-op just nearby. And he's going to talk about what is co-op life like and what co-ops do and why is it different from investor-owned utilities and public-owned utilities and some of the problems and challenges.
Okay.
So thank you so much, Bob. Bob is an alum of this university.
Thank you very much, and thank you, Professor Gross. I think Professor Gross got here just as I was leaving. I actually graduated in 1982. If you had Professor Sauer for any of your courses, he was one of my professors a long, long time ago. So, very familiar with the university and glad to be back. Glad to be here today. I hope to give you just a little bit of an idea of what I do on a daily basis, what cooperatives are, how they fit in with the industry. Talk a little bit about the U.S. and some of the changes that we're seeing in the supply and distribution markets. And then on a daily basis, what kind of challenges that I and our employees at our co-op deal with. So just give you a little bit of an overview. If you don't know it, you're very lucky to be in the power program here. This is a very well-respected program. Of course, the engineering at U of I is highly ranked. The power program is exceptionally highly ranked. And there aren't that many power programs left in the U.S. So this is a very good program here. So you should not have trouble finding work when you come out. So I'm Bob Hunzinger. I grew up just about 75 miles south of here. Graduated here in '82. I've worked in a variety of the industry since then. I'm a little unique in that I've worked in the investor-owned segment, the municipal segment, and the cooperative segment. Those are really the three parts in the U.S. of utilities. And for about the last 10 or 15 years, I've been in management. One of the bigger companies I managed was a municipal down in Florida, in Gainesville. That's where the University of Florida is. It's about a $400 million company. It was an integrated electric utility, meaning we generate our own electricity. It also had water, wastewater, gas, telecom, things like that. So that's just a little bit of my background. I've been very lucky in that I've always had the ability to do different jobs, no matter what organization I was in. And if I had a piece of advice for you, don't get too locked in to doing something specific. Try to broaden your experiences, even if they're outside of the utility industry, because down the road, that's going to pay dividends for you. The more experience you have, the better off you can be, especially with the pace of change with technology. So I'm going to talk about Eastern Illini in a little bit more detail. There we go. But first I want to talk about cooperatives. And I think these must be my old slides, but let me get to the right place here. I'll come back to those. So what's a co-op? Basically, we in this room could form a cooperative. It's a group of individuals that want to unite under a common cause. It could be an economic cause, it could be social, any number of things. These are some of the industries that have cooperatives. We'll talk a little bit more today about electricity. But here in Urbana, I think there's a food co-op called Common Ground. So that's a grocery co-op, if you will. And there's co-ops in virtually every part of business. In the U.S., I think that number is actually now, there's over 40,000 cooperatives in the U.S. that have over 100 million members. Worldwide, that number is something like 1 billion people are members of cooperatives. And of course, the population of the world right now is about 7 billion. And just keep in mind that that population by 2050 is going to be about 10 billion people. So we've got a lot of challenges ahead of us there. So how did co-op start? Well, some people think they started back in Philadelphia in this country about 250 years ago, where people joined together for fire protection. So fires were a big issue back then. If somebody lost their house, they'd lose everything, so they kind of went together. Probably the more modern part is about not quite 200 years ago in Rochdale, England. A number of business people went together to try to get better products, better prices for their products. And they designed a set of principles for cooperatives. I'm going to go through these pretty quick. They're in the slides later, but one is voluntary and open membership, so anybody can join. Democratic control, you have a vote in how the co-op operates. You participate economically through equity or cash as part of the business. You're independent and you're autonomous. You own and operate yourself. Very big on training and education. You cooperate with other cooperatives. I'll show you how that works in the electric industry a little bit. And you're involved in a community that you're members of. Just touch on a couple of those. Basically, most co-ops are not for profit. So any excess, which we call a margin, goes back into the business, either at the current level or go back to the members after a period of years. And then locally, we would help any other electric co-op that got in trouble. We would help municipals and investor-owned as well. So for example, in this part of the country, we're getting into winter pretty soon. And about every 10 years, we get hit with a major ice storm that pretty much takes out half or so of our system. We need a lot of help. We don't staff up to deal with things like that. So, we staff up to day-to-day business. So we would call in help from other individuals, other entities to help us there. Let's see. I'm going to go back now. I got these a little bit out of order. I apologize. And I'm going to talk about Eastern Illini. So we're what's considered an electric distribution cooperative. So if you want to look at us, we're like the last mile provider for electricity. So in town here, I assume some of you have Ameren or electric service if you have your own account. And we would be like Ameren, except we're in the rural areas. So we serve everything but Champaign-Urbana. We're all around it. The investor-owned's got a swath through here, so we serve the rural areas. This just happens to be some of our employees.
I'm one of your customers.
Hey, very good. Where do you live?
Homer.
All right.
Actually, one of your very good customers.
So far, he has paid his bill every month.
I use my share of Eastern Illini electricity, so.
I have to get your name later. Appreciate that.
I'll talk to you, don't worry.
So.
I know Bob Dickey pretty well.
Oh, yeah. I'm sorry for that.
Yeah.
Bob's doing well. So we have about 13,500 meters, and one of our biggest challenges is we have about 4,500 miles of line in service. That's 3 meters per mile of line. Now, there's a lot of fixed costs in 4,500 miles of line and the people and equipment to serve that. So we have about 56 employees. About half of those would be outside employees, linemen, for example, and then various other positions. And we serve parts of 10 counties, which is kind of a challenge. So we're really spread out. Now, our revenue is about $35 million a year, gross revenues. About 2/3 of that goes to purchase power. So how does that work for us? We're actually members of another cooperative. It's a generation transmission cooperative. So they're called Prairie Power. They're based out of Springfield, about 100 miles west of here. So they either generate the power or buy the power in the market. They send it through the transmission system, and then we have delivery points. We take it off the transmission system and deliver it to our members. So most of our system is 12,000 volts. However, we do have about 100 miles of 69,000 volt line. Like I mentioned, our big challenge, we have 3 members per mile of line. Co-op average in the U.S. is about 7.5. Investor-owned utilities like Ameren on average is about 35, 34. And the municipal utilities are even higher than that, obviously because they just serve the communities in the town, so they have a pretty high density. Our total plant value is a little short of $100 million in service, and we're fairly small. We only sell about 250,000 megawatt hours a year. So if you put that in the megawatts, our peak in the winter is about 60 megawatts, and our peak in the summer is about 50 megawatts. This would be one of our.
Do you have a lot of electric heating?
Oh, we do. Thank you, Professor Gross. And please ask questions throughout. So yeah, we have a lot of geothermal systems on our lines and a lot of electric heat.
You're responsible for the extra 10 megawatts.
Yeah. Quite that big, but.
So, geothermals, you use the ground to heat and cool. So you use loop pipes in the ground, and you take the heat out of the ground, and you heat the house in the winter and cool it in the summer. It's a very efficient way to heat and cool. Actually, it's much more efficient than heat pumps or central air conditioning.
So what do you guys own? That $100 million is basically copper and a couple of substations?
Yeah, we'd have roughly 25 substations in effect, and a lot of miles of poles, wires, and transformers. Very much so. This would be a typical substation you'd see from Eastern Illini. So on the left side here, the 69,000 volts come into the A-frame. It comes down through a switch, a set of fuses. It goes into the transformer. That's a 5,000 kVA transformer, maximum rating to be about 7,500. And then it comes out of the transformer at 12,000 volts into the low side bus, and then it will go out to our customers from there. Now on this, there's two sets of regulators, which are these kind of cylindrical devices here. So there's two circuits coming out of this sub. So that would be a typical sub. This is probably one of our newer substations, and it was built probably in the late 1980s. Now, this year we're actually building 3 new substations because we've got some growth and some areas of concern in our system. So those will be the first new subs in our system in about 30 years. I mentioned a little bit that we purchase energy from another cooperative, and about 2/3 of that energy comes from a power plant, coal-fired power plant. I'll have to show you that later. I think I updated this presentation a little bit, but so Prairie State is a new coal plant that's down in southwestern Illinois, just southeast of St. Louis. It's been online about 3 years. It's probably one of the last coal plants that's going to go online in the U.S. Why is that? Well, if you've been following climate change worldwide, you know that issue of carbon and the impact that it's had on the climate. In the U.S. at least, the Environmental Protection Agency has promulgated rules that will make it very hard to build new coal-fired power plants. Virtually impossible. So this plant went online before these new regulations. This has been on about 3 years. It's a highly efficient plant for a coal plant. It's supercritical. What's that mean? It has high steam pressure and high temperatures, and therefore it runs more efficient than a typical coal plant. But it still puts out a lot of carbon dioxide. So that's about 2/3 of the energy we buy.
I got a chance to tour the coal mine right there.
You did?
Yeah, it's a very clean mine.
What did you think?
I loved it. I wish we could take these guys on a tour.
Right.
He's probably going to move closer to be next to the mine mouth plant, okay?
Well, the coal is mined, it goes across the road and it's burned.
Yeah, you're Professor Ogilvy, right?
Yeah.
It just dawned on me. Yeah, when I first knew Professor Ogilvy, he had a lot more hair.
The days.
Of course, I had hair
He
too.
cuts it very short now.
Yeah, it's getting shorter and shorter.
But so like Professor Ogilvy said, it is a mine mount plant, and so it's a very low fuel cost. And the challenge of that mine is that the coal's coming out of the mine unwashed. At a BTU content, it's fairly low, but it has a high ash content. When you burn that coal in the boiler, the ash causes issues like slagging, and it causes a number of other problems in the boiler. So anyway, that's 2/3 of our energy. About a third comes from market purchases. Either I make a deal with one of you and we agree to some price over a period of years, or we just purchase it on the market itself. And then we have also some wind power. There's a wind farm just up at Paxton where I work, just east of town. About 4% of our energy comes out of the wind farm. This is just a picture of some of our employees. This is actually our operating center. I make an offer for anybody to come up and visit if you'd like. I've got some cards later. But the building we're in is probably built in the early 50s. We do have the capability to monitor our system, and we don't have a lot of control of our systems yet at this time. We're looking at putting in some systems, trying to pilot some programs that if we have outages to get the members and customers back on quicker. So let me talk a little bit about.
So any physical threats to your system?
Not too many, Professor Gross, at this time. Occasionally we'll get some individuals that like to use our insulators and our substations for target practice, or regulators, and that can cause some issues. Probably we're more concerned about cyber issues, and not so much from the system side at this time, but more from the customer information side. So
according to the data from the Department of Energy, which USA Today published, out of something like 1,400 plus actual hackings, 159 were successful.
Mm-hmm. Yeah.
So you should be concerned. This is the data they make available.
Right.
So there's a lot more data that may not be available.
Certainly. So let me tell you a little bit more about us. We're governed by a board of directors. They're elected. I mentioned we serve 10 different counties, and we have 9 directors. So it seems like a lot, especially with just 13,000 members. We used to have a lot more. In fact, what is now Eastern Illini used to be 2 separate cooperatives. One was Illini here in Champaign, Eastern up north. They merged, and over the period of years, the directors went down to 9. That's a pretty comparable number. I don't see that changing much. They serve 3-year terms, so they're elected by the members, and our board members don't have term limits, so we have some board members that have served for almost 30 years. So you get a lot, that's good and bad. You get a lot of experience, but you don't get a lot of turnover and new ideas, unless it's coming from the staff. So what's the board's function? Primarily to set the policy direction for the organization, and it's fiduciary, make sure that we have enough money and we're doing what we need to do there. So here's some of the corporate goals that we track. One is safety. It's very important. We want to make sure and be safe with our work, not only for our employees, but also the general public. I'm going to give you some examples later. We track member satisfaction. So our customers, like Professor Overby, how well do they think we're doing in various areas? We track financial metrics, so cost and other things relative to the money we borrow and how efficient we are. And then what's our big advantage for the call? It's service to members. So we serve the rural areas. We've been around for about 75 years. And so let me go into that a little bit, like Professor Gross mentioned, from the electric co-op side. Sorry about that. Okay, so as was mentioned, back in the mid-30s, if you lived in the United States, primarily just the cities and the urban areas had electricity. If you lived in the rural areas, very, very small percent, this says less than 10% had electricity. So the federal government stepped in. The president at that time was Roosevelt. He actually signed something called the Rural Electrification Act, and it was government assistance through low-interest loans to start entities like us, cooperatives, in the rural areas to provide electricity. Now, a lot of it was centered in the Tennessee Valley Authority. A lot of new generation was built in that area. But in this area, it started in the late 1930s. So why was that important? Well, within the space of about 20 years, that percentage of rural people that had electricity went from 10% to 90%. Today, as Professor Gross said, virtually everybody in the U.S. has electricity. So internationally, that's not something that we can say. We have a lot of countries that are trying to get to a middle-class economy, a lot of people. This is going to be one way that those countries can get to that point. The U.S., our co-op association has some programs where we actually try to help internationally. We're just now starting programs in Africa. They've been involved in the Philippines for about 50 years. And we've sent individuals to, for example, India, Pakistan, Bangladesh before as well. So that's going to be the key as the population gets to that number I mentioned earlier down the road of how those societies can help deal with that. So nationally, this is kind of a map of the areas that co-op serves. If you look at that, it's about 75% of the land mass in the U.S. is served by a cooperative. However, with that 75%, we only have about 11% of the kilowatt-hour sales nationally. So we have a lot of territory, but not a lot of load. Get my notes.
There's a co-op just in one of the islands of Hawaii.
Mm-hmm. Correct. So they're in 47 states, and I think the states that aren't covered are up Connecticut, Rhode Island, and one of the others in the Northeast. So big part of the land mass, but only about 11% of the sales. And we also have 42% of the distribution line miles that are installed in the U.S. So you can see we're very rural. If you drive around Champaign, if you get out of town sometime, this is some of the best farm ground in the world. And you can see why we only have 3 meters per mile of line. There may be only a house or two each mile. So we've got a lot of line and service to serve that. Whoops.
I have a question to ask.
Yes.
If I understand well, with the rural electrification, the area is too big and big dispersion of customer. So my question is how the electrical losses problem is challenging for you, and how do you try to mitigate the losses through the power grid?
Okay. If I understood your question right, variations in load?
Yeah, the losses, because the distribution line are
Oh, the loss.
dispersion,
Yeah.
Yes.
Okay, gotcha. Yeah, if you look at Eastern Line, we average about 7.5% losses. Now that's a lot, but we have 4,500 miles of line and service. We have a lot of subs. So typical distribution losses, help me out here, 2%.
Well, we say that distribution losses are higher. Usually we'll say like 10%. So
Oh, really?
yeah. I mean, transmission is lower, but distribution is pretty high.
Right.
Transmission in the U.S. is somewhere between 2 and 4%.
Yeah,
Okay.
transmission is low, but distribution tends to be pretty high.
Right.
That's probably because of the rural.
Yeah.
I mean, we just have a lot of people out on the lines.
Right.
A lot of space.
But I think this is a problem with co-ops in terms of the business model, the density of the population.
Right. Right.
Some of us like that with densities.
Right.
But that's why you're not in that business, you're in the teaching business, okay?
Yeah, but is it possible to put in a different file, or would that violate? So I've got some other slides I've updated. I wanted to touch on a couple other things. The question is what I do with that.
Oh, so it's still sitting here somewhere? Did you give
Did I
it to me?
did I give that to you?
Oh, yeah, I guess you did. It's this one. Right?
It was a board one. Had a blue.
Yeah.
We're going to try to load that up, but while we're doing that, let me talk a little bit about the industry in general. So, we're about 10% of this, well, 11 or 12% of sales in the U.S. The investor owns like Ameren, who serves Champaign, Urbana. In total, they're about 75% of the
Not anymore. They're down to about 67.
Okay, thank you. And the municipals then make up the balance.
Which file do you want?
The nearest,
This is the correct one.
I think so, but yeah, no, it's wrong.
Okay.
that's fine. So the municipals will make up the balance. The nearest municipal is in Rantoul, and it's a very small municipal. So if you look at co-ops across the country, we're kind of the typical co-op of our size. We're right in the middle. We're the median co-op, not for density, but for number of people. We're actually considered fairly good-sized cooperative. So there's 900 plus in the U.S. About 840 of those are distribution cooperatives, and some of them have as few as 1,000 meters. So what are some of our issues? Well, for one thing, we're too small. And in Illinois itself, there's 26 electric distribution cooperatives like us. And in this part of the state, we have about 5 co-ops that probably should merge together and become one co-op. There's some barriers to that. I mentioned we have board of directors and have that local control. People like to operate their own co-op, right? You want to be the boss of your own thing. So a lot of that is hard for that. A lot of that inertia is hard to overcome. So I'm fairly new back in Illinois. Been back about 2 years. Those co-ops I mentioned around us, the managers of those organizations have all changed within the last 2 years. So it would have been an ideal time to bring those co-ops together. It just wasn't something that we were able to get done. So our size and our density are issues. Our cost to serve. Professor Overby is one of our members. He knows well that we're a little higher than Emory. There's reasons for that. We have higher fixed costs because we have a lower density. However, that's one of our big challenges, to try to maintain the system in a reliable fashion, but still do it in a cost-effective manner. Another problem or concern that we have is hiring quality personnel all throughout our system, mainly the technical and the people that would work on the lines. But co-ops have about 70,000 employees nationwide. Half of those jobs are going to turn over in the next 10 years, all throughout the organization, from my level on down to administrative people. The same thing's happening in the utility industry in general in the U.S. So does anybody know how many total people work in that industry in the U.S.? Any guess?
About half. The other half take it easy.
Depends on which day it is. But there's going to be tremendous opportunity in the next decade, at least in the U.S. and probably worldwide too, for utilities. Now, another challenge that we have is we have changing demographics. If you look at our membership, we have a very old member base. Believe it or not, there's a few people on the lines that remember when they first got electricity back in the early 40s. Not too many anymore. But as those members get older and pass along or move off our lines, they're replaced by, hopefully, by younger members. We virtually have zero customer growth. We are getting some load growth. And as those members change to a younger audience, like you, those members no longer have the loyalty that their parents or grandparents had for cooperatives. So the cooperative business model, one of the big things in the future is that will that model stay as it's been for 75 years? We think it's going to change quite a bit. If you layer on top of that, we're seeing tremendous change in the industry. We're seeing change on the generation side. I'm sorry I didn't bring a slide, but renewables. So let's talk a little bit about what's happened in the U.S. I mentioned the EPA changes relative to generation supply. If the EPA plan as proposed, and it'll become law soon, they have to file it with the Federal Register, and then for I think 60, 90 days after that it becomes law. If it passes the and stands up to challenges in the court system, in 2022, in the United States at least, there's going to be a drastic change in generation of electricity. So what you're going to see start happening is coal plants are going to start getting phased out. Anything that generates carbon, that would include natural gas, although they're more efficient. They put out about half the amount of carbon than a coal plant does. You're going to see a switch towards renewables like wind and like solar, perhaps battery storage technology, perhaps more electric vehicles that are going to charge the system at night. So the supply side is going to change drastically. So we're going from a carbon fossil-based more towards a renewable. So what happens when you see that on the supply side? Well, it's going to affect the stability of the system. So right now we've got a lot of rotating machines out there that they handle as the load goes up and down. The system automatically adjusts. But if you have a lot more renewables coming on, it's a lot bigger engineering problem to make sure the system stays stable. Are you guys teaching any classes with that?
Right. Next semester, 576, we talked about dynamics.
Okay.
Got some students doing research on that. Is he here? Oh. He's working on that.
I assume you're following Germany closely?
Follow a lot of countries.
But, with
we try not to emulate the same
Yeah.
mistakes. And so far, we're doing well. I mean, Germany, which has about, 1/7 of the population we have,
right.
they only, in terms of wind, they have half the amount of megawatts we have. That's all.
Right. So that's one thing that's going to change in the future on the supply side. On the load side, or the consumer side, there's a number of other changes as well. So, how many are familiar with Tesla and the electric vehicles they're producing? Pretty short cars, right?
They know Tesla's engineer, and they don't know him necessarily as the father of the electric vehicle.
Okay. All right. But as you know, Tesla's building an automotive factory out in Nevada, and I would postulate that it's really
Battery
not.
factory.
It's not exactly. It's not a car factory. It's going to be a battery plant, right? So, what's the market they're after? Solar and wind are becoming much more efficient. We have some wind contracts right now. The ones up at the Paxton I mentioned. Right now, we're paying about 4.2 cents a kilowatt hour. Not bad. A coal plant on the margin is probably under 2 cents right now if you have a good coal supply. But solar, large solar installations are coming down in the range of 5 cents a kilowatt hour, which isn't bad. U of I's putting one in now. Theirs is a little more than 5 cents, but
We pay 15,
I saw that.
but we're going to own that plant in 10 years.
Right,
And then it's going to cost us zero.
right. So on
If
a
it still
30-year,
produces electricity, if it
Yeah.
doesn't, then we have to buy more expensive electricity.
but on a 30-year basis, it's going to be a lot different than 15. So if you haven't seen it, it's just south of Mungie Road and just east of First Street, just west of First Street. So that's changing. If you wanted to put solar in your house right now, if you put like a 10 kW system on a roof or a ground mounted, the payback on that's probably greater than 15 years. So probably not the best place to put your money. But if you paired that with battery technology, where you could generate the energy during the day, store it, use it at night, virtually get off the grid, with the exception of still having a tie in case something went wrong, then that's a little different dynamic. So how that plays out in the electric industry in the next, say, 10 to 20 years is really going to impact the business of cooperatives and other investor-owned and municipals that deliver that energy. So that's probably one of the concerns that we have going forward is how's that going to shake out and how can we interact with that? Can we be a part of that? Does it make sense for us to be in the solar business? Maybe be in the battery business and install things like that. So, there's no question that over the last 75 years, the quality of life in the rural areas has increased dramatically because of electricity. But what's the next big breakthrough? So those are the kind of things we're looking at trying to think about. The co-ops in the United States at least have a very big voice. We have a big lobby nationally. So as you can see, we're in virtually every state. Every state has politicians. We have very good relationships with those politicians. So even though we have maybe 12% of the customer base, we have a much bigger voice than that nationally when it comes to political issues. So we try to maximize that as well. So let me touch a little bit on the smart grid. I'm sorry I had a slide that didn't get in my show, but yeah, go ahead.
I have a question like what's the major difference? Why doesn't like Amber serve like the local customers or like the clubs? Or like
Yeah. Oh, that's a good question. I probably glossed over that. So the question is, why doesn't Ameren serve in rural areas, or why don't the co-op serve in urban areas?
Is this perspective like why?
Mhm. That's a really good question, because back in the 30s, the investor owners at the time didn't find it cost effective to extend out into rural areas. So not many customers, not a lot of electric load. So it was a money losing proposition for them to extend out into rural areas. So they tried to stay in the city, like Chicago, for example, where they had a lot of density and where they could make money. So they just neglected the rural areas. That's why the government stepped in with low interest money to allow co-ops to start. So that led to a lot of economic development in the areas that we now serve, in the rural areas.
Would the law allow them to get some of those low interest loans in the 1930s, or it was specifically for co-ops?
Yeah, Professor Gross just made a very good point. There was a really contentious battle at that time. The investor-owned and the stock-owned companies did not want cooperatives to have access to low-interest loans, and they actually tried to stop that and block that. So once that became law, over the years, there were many attempts in Congress to try to pull away that low-interest funding. And right now, by the way, about half the co-ops, probably more than half, do not rely on low-interest government funding anymore. So we basically go to private banks or cooperative banks that offer that same funding.
But I guess his question was, okay, why couldn't Ameren go get the low interest loan? I mean, because the loan was available, right? So why wouldn't the investor-owned, were the investor-owned companies prohibited from getting a low interest loan?
Yeah, effectively, the law was such that it was only a certain group that could get those loans, and that was electric cooperatives. That's where the laws were written at that time. But it was a huge issue. And by the way, we have a fairly good relationship right now from an operating level with Ameren in this local area. That's changed over the years. In effect, Ameren is now, in Illinois, it's a deregulated state, meaning that the generation's been deregulated. It's basically market-based generation. And so the transmission and distribution are still somewhat regulated. However, the investor-owned customers like you can choose your supplier. So it doesn't have to be Ameren, it could be a third party. They're called retail energy suppliers. If you're a member of a co-op or municipal, you don't have that choice. So by state law, the choice is only with investor-owned customers. That's another issue that could change in the near future, depending on what happens, a variety of things. So, from the distribution side, the penetration of solar and other renewables, but probably solar and battery technology, could drastically change how we do our job on a daily basis. So to get into the question, a little conversation we're having before the meeting started, you've all heard the concept of smart grid. You've probably studied it in various farms. And by the way, smart grid's definition is as big as this room. It can be whatever you want it to be. However, let's define it that there's changes on the distribution system on reliability. How often, well, first of all, how reliable is your grid? How can you make it more reliable? Can you automate your grid to get customers back in service, to isolate faults, and return individuals back to service faster. That's part of it. The other part's information. So virtually everybody today has or will be putting in smart meters, electronic meters, typically two-way communications. At Eastern, we have an old metering technology. It's, we can read the meters. It was put in probably in the late 90s, early 2000s. So we can read Professor Ogilvy's meter remotely. We can provide him data on an hourly basis with a little delay. But we don't have two-way capability to that meter where we can control devices yet. So a lot of companies like Gamma are putting in meters that ultimately they may be able to control your washer, your dryer, your freezers, your refrigerators, your air conditioners, your water heaters. So there's a big, the next big item I think is going to come out on the distribution side is two things. One is control of that end user. So everything's getting an internet protocol now that's being manufactured. So that'll be coming out. So how does that get controlled? Is it going to be controlled by the utilities through the metering? Or is it going to be controlled by a third party through the internet? And there's going to be tremendous growth in companies that develop that internet-based protocol. So if you can control load and capacity or the use of energy, can you shift that to a later time? Can you reduce the peak at a particular time? That has value in the market because capacity is expensive. When you use that electricity, it's a value. So if somebody can develop ways to control that load and sell that to people like us, that has a value. Alternatively, utilities are looking at that to want to control that themselves. What do you guys think? Where's that headed?
Well, I think there's going to be very little change as far as I'm concerned in this rural landscape.
Mm-hmm.
And essentially for the reasons we talked about, that this is the most prestigious position you have if you're on the board of trustees of the local co-op. I think utilities would love to get into this because that infrastructure would help them and they could grow. But that's not the battles they're going to fight.
Right. The other thing that, as solar and renewables penetrates and storage technology penetrates into the distribution level, is again, it's stability issues. So how much solar can a circuit take? It's a big economic issue. So if you put in your own solar and storage technology, you're virtually buying nothing from the utility. So we've got lines in service that we're not making any recovery on, not getting economic benefit from. So who should pay that cost? Should you as a solar customer, somebody that's put in solar, pay that cost 100%, 50%? Should that cost be transferred to all of our other members? That's a big issue nationally on how that's done. And if you look at some of the research or Google that issue, there's a number of different states that are trying to tackle that in different ways. And it's not an easy economic answer. The bottom line is somebody's got to pay for that. The question is, how do you allocate those costs? So those are some of the things that are coming down the road in the future. Just to look at. There's going to be tremendous, like I said, there'll be a tremendous opportunity for someone that figures out the best way to do some of these things. Communication is going to be a big issue in the smart grid. So is that done through the internet? Is that done through radio technology? Those are typically the two that you see right now. And how that interacts with all these devices out there. How can you monetize that?
Excuse me.
Yes.
About solar generation, I wanted to know how a state like California and Texas and other states, they are doing better. We can see solar everywhere in almost of houses, but in Illinois, I think it's not the case.
Right.
What is the real problem?
Okay, so the question is why do some states have a lot of solar saturation or installations and other states don't? And some of it is just geographical in the amount of solar available. So California has a lot of solar available. Arizona has a lot of solar available in the Southwest. I used to work in Florida, We actually developed the first feed-in tariff in the United States in the municipal I worked at. And that subsidy created a lot of solar in that community. So there's a couple issues. One is geographical and how much solar radiation there is available. The other is it subsidized at the state or national level? And so right now in the United States, there's a 30% tax credit if you install solar. I think that expires at the end of 2016.
Right.
So it'll probably get extended, but let's say it expires at the end of 2016.
Are you willing to take a bet? I mean, there's certain odds for any one of these bets. I would say most unlikely now.
Okay.
Let me add to that too, Bob. We actually talk about Eastern Illini rates in our EC 333
Okay.
class, which is green electric energy, and when I teach it.
Right.
I don't know if George talks about them. But we then talk about Pacific Gas Electric rates, and Eastern Illini rates are much, much lower than Pacific Gas Electric. And out there, the more you use, the higher you pay.
Right.
So if you're a high-end user, such as myself, I would be paying a very high incremental cost. If I paid that cost, I would have my house covered in solar. I pay Eastern Illini's electric heating rate 8 months of the year.
Right.
I don't have a lot of incentive to put solar in because the rates are relatively low.
Right.
So if you have high rates, as in California, you're going to give the high-end customers, the faculty and people like that who can afford to put it on their roof, incentive to do it. So they're going to do it.
Right. Yeah.
But be aware that the net metering in California is at retail rates.
Right.
So the utilities' choice would be to buy wholesale.
Right.
They're buying from you at retail rates. So it's going to be very soon this death spiral, which is going to hit them.
Right. And that was kind of the other part of it. So you got where geographically how much radiation you see, what are the subsidies? They're the same federally, but each state may subsidize it. What's the policy, like Professor Gross said? In Illinois, there is net metering. You can offset your retail rate. On Eastern Illini system, it's up to 10 kW, which isn't very big. That would handle typical residents. But if you go above 10 kW, you're going to get the, not the retail rate, but you just basically can get paid the wholesale rate. Which right now for us, the incremental rate is about 3 to 4 cents. Marginal rate on the avoided cost. So, yes, sir.
As a co-op, do you feel like it's fair that you would pay somebody on their solar installation retail rate because they're no longer paying them for the transmission maintenance and all of that?
No. And let me explain that though. I said earlier that co-ops aren't subject to regulation in Illinois, neither municipals. One of the ways we try to stay out of being regulated by the state or the Illinois Commerce Commission is we try to offer programs similar to what the investor owners do. One of them is net metering. So before I came back to the state, let's say about 5 years ago, that was a big issue politically. And basically the co-ops all got together and said, you know, we really need to offer a net metering rate because the investor owners are. And if we don't offer this, the politicians may want to put us under some more jurisdictional control. So virtually every co-op has a net metering rate. It's just that we keep it fairly low. I think if you're an Ameren customer, you go up 30 kW. Ours is about 10. Different co-ops have different levels. But that's a good question because, you know, being in the utility business is more than just the business. You got to look at the political side too. So it's a really good question on the solar, and it really depends on those subsidies and how each state wants to treat that.
Is there any example where any state has tried to regulate co-ops?
Co-ops are regulated in Indiana, for example, on a retail basis, on a rate basis. So certain states do regulate co-ops from the business side. So if we were in Indiana, we would have to justify our rate increases to the state utility commission. In Illinois, our board, in the course of one meeting, if they wanted to, of course, you know, we'd have to justify it, they can raise or lower rates. It's complete local control.
I wasn't aware because it's a federal act that created the co-ops.
Right.
And I wasn't aware that anywhere they were under state jurisdiction, but you gave me a good counterexample.
Right. Yeah,
Does Indiana have any municipal systems?
they have quite a few municipal systems as well. I don't know, Professor Gross, if they're under that or not.
Usually not.
Yeah, usually it's at local
Yeah.
governmental control. Yes?
So you mentioned that some co-ops are not for profit or at least investor co-ops. So what kind of things do you look for when you lobby? Like what kind of, I guess, laws or regulations do you look for things to be?
Sure. Well, let me give you a good example with the environmental issues in the clean power plant. Even though co-ops generate very little of their energy, and a lot of it's purchased from the market, I think about half the energy that co-ops use is probably generated internally by other cooperatives. Most of that is coal-based or fossil fuel-based. So there would be a disparate economic effect if the EPA regulations, as they're proposed and went through the final rule, would be implemented on co-ops versus perhaps the rest of the industry. So that was a big issue. So the co-ops spent a lot of time lobbying that issue of equity, and that we serve generally poor areas, and that would have a disparate effect on the members that we serve. So that's an example from that standpoint. From the business side, we're not subject to federal or state tax, as long as you have 85% of your incomes come from a cooperative venture. Now, if we had a subsidiary and that was over 15% of income, then we would go into the tax bracket. So some of that's just got to be careful what businesses you get into and how big that is. But that's an example of our lobbying efforts. Territorial issues. In Illinois, those have pretty much been settled over the years. Every place has a defined territory. One thing I wanted to mention to you is that, I showed you earlier that we have about 250,000 megawatt hours a year. For the past 3 or 4 years, we've been working with a proposed fertilizer plant down in Tuscola, about 30 miles south of Champaign. That one plant itself would have more energy per year than all of our members combined. So hopefully we'll be able to attract that industry. We've been working with them on a contractual basis. But the property that plant was going to land on was split between us and Ameren. So it took us about 2 years to work that issue out with Ameren. So that just gives you another example of things that we'd be working on. What other questions might you have? I'm pretty much done, I think, with what I had. I've got some cards if you want them later. I appreciate the opportunity to be here, and so open to any questions at all.
What's next with us?
What's next?
Yeah,
With co-ops?
with the university, with students, with the research.
Well, I'm not sure I can answer that. But I can tell you, I probably would not be able to get into the double E department right now with the quality of students you're attracting. I can tell you that. So I'm glad I did. I got in when I did.
Got an exam in my class tomorrow, so we'll see what this
All right.
What do you have a quiz?
Exam.
Let me. So Professor Gross had asked me, kind of what keeps me up at night, or what things are really big concerns. And then let me just give you a couple examples here. The first and foremost is safety. Why is safety important? Because we never want one of our employees to not make it back to work, to not be able to go home to their family, to not be a part of that family. Let me give you a couple examples that happened within the last 2 months in Illinois. There's a co-op in the southern part of the state, probably about 150 miles south of here. Very dangerous job. It was after storm damage. They were repairing services. Lineman was up on a pole, apparently thought that the line was dead. It was not. That individual contacted the phase, which is 7,200 volts to ground, and his other hand contacted the neutral. So he put his body in between 7,200 volts, went through one arm, out the other. Probably should have killed him. It didn't. He's still in the hospital in St. Louis. He had both arms amputated below the shoulder. So his life will never be the same. So that's the one thing I worry about every day, is that our people come back safe. I worry about the general public. We give another example. About a year ago, this is a big harvesting area. We had a truck that hydraulic lift. It didn't watch what it was doing. I don't know, it was dumping grain or something, and it raised its bed into a 3-phase line. Well, the truck basically caught on fire. The individual that was driving the truck was smart enough to jump out of the truck and not try to step down off the truck. And so the truck was a total loss. This individual happened to be okay, but that happens more than we'd like to see. We also have a lot of farm implements that hit our lines, and that's very dangerous as well. So I just checked before I came. Last 2 weeks, we've had about 14 incidents of lines torn down from farm equipment catching the lines. The farm equipment's is taller than the ceiling, and hopefully our lines are proper height. We talked about cost already, trying to keep the lights on. Ice storms are my biggest concern in this part of the country, not so much summer storms, although they can really cause a lot of damage, occasional tornadoes, but ice storms where you can lose your whole system. It would take weeks, perhaps, to get service back up. That's something we worry about. We talked about the regulatory impacts, what's going to happen. Eastern Illini is basically stable. Professor Overby, you'd like to hear this. Our rates should be stable for the next 5 to 7 years. Why? Because we invested in that coal-fired power plant with low fuel costs until the environmental regulations might impact us.
That's for concern.
Right? So he's paying a little bit more now, but everybody else is catching up because the market's going to start coming up.
Why don't those co-ops build solar plants?
Well, some of them are.
Where?
Interesting enough, Prairie Power, who we're a part of, they're putting in 2 500 kW systems. They're going to allow our members to buy into part of those.
Okay.
Some of the larger co-ops are building larger systems, that make more economic sense.
But you guys cannot have those tax credits, right? Because you're not tax-paying entity.
Very good point. However, if you go in with a third party, like one of our co-op banks, they can take those tax credits or sell them. And so they work that deal out.
Okay.
So there's ways that they can take advantage of that. And then, like we talked about a little bit, what's the future of the grid going to be, and that changing technology on the supply side and on the customer side. I think that's going to change tremendously. How it impacts the co-op is still up in the air, and we'll see how that works out.
Okay.
So I appreciate your time, and
Thanks a lot.
thank you. Thank you.
Nice to get a story like this. You
Yeah.
delivered very well.
Thank you.
So thanks for coming.
Yeah, you guys are getting Canada.
We were going to get
I thought that was hilarious.
Yeah.
I like those kind of.
Right. That would be